2, 1, and we are going live.
All right, great. Welcome everybody to the Shardus Q3 2021 presentation. We have some really interesting stuff in store for you. So let me get my screen sharing going. Okay, Amr, is that visible? Can somebody just tell me?
Yeah, you're good to go.
All right, sounds good. Okay, great. So yeah, welcome to our quarterly event. And if you're new to Shardus, we do these quarterly events each quarter. We've been doing it since the start of the project, and we upload these on YouTube, so you can always go back and review these. Okay, so our agenda today, basically, I'm going to talk to you a little bit about like what Shardus is for those that are not familiar with it, and then Shahzad is going to talk to you about some of the things that we've been doing this quarter, and then we're going to do a demo of PeerSwap, and then a demo of Shardus, and hopefully we'll show you some pretty amazing stuff today. So, all right, let's get started. For those that don't know what Shardus is, basically Shardus is software that developers can use to create an application-specific decentralized network. So we take care of the whole protocol layer, where the nodes are talking to each other, the consensus, nodes joining, exiting, all these things, keeping the nodes synchronized. We take care of all that. Then that way the developers can just focus on the application layer, building APIs and then building front-end clients to communicate with those APIs, and then that creates a application-specific decentralized network. So one of our main focus is to make the development really easy. The experience of developing with Shardus, making that very easy for the developers. And one thing that we're not is a smart contract platform. So a lot of people, when they hear about Shardus, they think maybe we're trying to deploy like a smart contract platform. No, we're just building the underlying software. Now, somebody can take the Shardus software and add a Ethereum virtual machine to it and create a smart contract platform. Okay, so why are we building Shardus? Well, basically, we started the project because we had some applications that we wanted to build ourselves, and they required a really, really high amount of scalability. Maybe like being able to handle like 1 billion daily active users and getting into millions of transactions per second. And we also wanted to do that in a very decentralized way. And also, if you're familiar with the early blockchains, they used proof of work. So we didn't want to use a proof of work system because of the energy expenditures. We also want to make the system very easy, as I mentioned before, for the developers. And finally, we want it to be very interoperable, so that different blockchains built with Shardus can talk to other blockchains built with Shardus, but also be able to communicate with other existing blockchains that are out there, like Bitcoin, Ethereum, and so forth. And part of that interoperability comes from being able to build your own oracles and actuators within Shardus itself. So, all right. So now I'm going to turn it over to Shahzad, and he's going to tell you a little bit about what we've been doing.
Thank you very much. Welcome again to the Shardus Q3 presentation 2021. The philosophy at Shardus has been that we wanted to first walk the walk before we did the talk on it. So far, we've been focusing on developing the software, But from a marketing and business development standpoint, we have started building a lot of relationships, a lot of partnerships that we are getting ready to execute in the very near future once we are ready and have the software fully functional. At this point in time, a lot of grassroots marketing, a lot of presentations, conferences and podcasts. Umar Sayed has been talking at various forums, including the Wyoming blockchain earlier this year, the IEEE in Dallas, and he would be speaking at the IEEE National Conference on October 21st. We also did a presentation at the Swiss Crypto Valley last month, and in July, we spoke at the North American Basic Income Guarantee Conference, which was a conference on creating a UBI based on the blockchain. That was a presentation which we did there. Other than that, we've also been talking at various universities, doing a lot of podcasts, and focusing on the technical arena where we get a lot of ground level support started. Other than this, some of our uh, partnerships and alliances which we have built so far, and this is just a snapshot. Uh, the first one being the payment network for the African Union, APN. We also have been working with a healthcare transparency and payment uh, program with Blood. They've already started testing their project on Shardus. We're working with Lambda on a Python-based smart contract platform. We're also in talks with a realtor group out of Colombia where they want to do a land and title validation process there. Another group we are working actively is a payment network for an American faith-based organization where they want to uh, collect their charities and disperse them through a payment network built on Shardus. And we are in very early stage discussions with NASA for a project which they're looking at using a blockchain platform. We are one of the contenders, hopefully. And other than this, we have also identified a lot of partners who would be working with us on a marketing and advertising forum. And hopefully, there should be announcements at that end very shortly, moving into the last quarter of the year. With that, I hand it back to Umar Saeed to talk about one of our newest developments on Shardus called PeerSwap.
All right, thank you. So yeah, the progress this quarter on the technical side, there's been a lot of small things, but I'm just covering like the major things here. So we've been developing a an application with Shardus called PeerSwap, and we'll get into more of that a little bit later. Um, Also, we've had to develop a new monitor client for viewing like really large networks. So that was quite a bit of work. And then we've also developed an orchestrator for being able to send many transactions at the same time to do the load testing on our networks. And we've now gotten approved from AWS to be able to launch up to 17,000 servers on AWS, and so we've so far been able to get 1,000 node network working, and we're hopefully going to demonstrate that for you today. So with that, let me tell you a little bit about PeerSwap. So if you've ever created a coin and and created your own blockchain, for example, one of the first things you're going to run into is, well, how do I get this listed on some exchange so that people can acquire that coin? And so you'll end up finding out that exchanges are basically gatekeepers, and this applies not just to centralized exchanges, but also even the decentralized exchanges. The reason why the decentralized exchanges are gatekeepers is because even though you might be able to add liquidity for your coin or token, getting the decentralized exchange to have that show up in their native interface is still requires talking to people and convincing them that your project is big enough and things like that. So this kind of becomes an issue for new chains that are trying to get started. And we kind of realize that once we launch Shardus and people go and build uh, new chains using Shardus, they're going to run into this problem. So we were thinking about this, and we realized what's really needed is a trustless way for entities to be able to do exchange of any asset for another asset, and it could be on different chains even. And the trustless part of it is guaranteed by using deposits and bonds. And then if anything goes wrong, then we can have like a decentralized dispute resolution system. And so we've been working towards building this, and we're not completely there yet, but we can show you what we've got so far. So with that, I'm going to turn it over to Kyle and Amir, and let me stop sharing my screen.
All right, perfect. Can everyone hear me?
Yeah, loud and clear.
All right, sweet. So hey guys, thanks for checking out our Q3 presentation this Saturday, or if you're from the future, whenever you happen to see this. Amir and I will be demonstrating an app that I've been working on this quarter called PeerSwap. So up until now, if you've been following Shardus, you've mainly only seen applications that deal with sending like tokens or messages between users, and also the ability for any user to change the network parameters through proposals that can get voted on by the community. And today we're taking Shardus a step further to demonstrate how it could be used for a decentralized cross-chain swap service. So let's get right into it. I'll share my screen. Go to PeerSwap here. So the first thing users see when they visit the site is a welcome page with a simple timeline graphic of information on how to get started. When the app is complete, we will have an automated market maker that will allow users to swap between DAI and PeerSwap DAI for use on the platform in the form of collateral used for swaps. Below the timeline, we can see options for register and import private key. But since we're starting from scratch and don't already have an account, we'll just be clicking register. All you need to do here is enter your desired user alias and hit register. The alert above will notify you if the alias you chose has already been registered. So I'm just going to enter my name and then hit register, and then Amir's going to do the same with his name. When the server completes the registration process, you get redirected to your dashboard, which is right here, where you can see your account balance, your swaps, and your bids. And since this is a new account, we don't see anything in those sections yet, but we'll come back to this page in a bit. Below the account info, there's also a few filter settings for finding specific swaps of yours that you want displayed. You can enter tokens separated by spaces here, like BTC and ETH, and hit enter, and those show up as like little tags that you can, exit. But anyway, it'll only show you your swaps that have those tokens, and then you can also filter by status or swap type. So going forward, you may hear terms like initiator and provider. Initiator just refers to a user who initiates a swap or creates a swap, and then provider refers to a user who bids on a swap. And before we get into the process of making swaps, I'll hand the baton over to Amir to talk about some of the features we kept from LibreDex. So let me stop sharing my screen here.
Alrighty, and let me go ahead and share my screen. Can you guys hear me?
Yep, you're good.
Alrighty. So PeerSwap kept most of the features that we had in LibreDex, but for the sake of time and simplicity, we won't submit any transfers or proposals. Instead, we'll just show you where they are. For sending tokens, we can hit the send right here under the account info. This takes us to the wallet page, which you can also find by clicking the bank icon on the nav bar on the left. For receiving tokens, we can hit the receive tab. Oh. Looks like something happened there. Oh, back in. Let me just see if I can sign out and sign back in. Okay, there we go. All right, so I was talking about the wallet tab, and we had done send, and we have receive. There we go. All right, so the governance system for changing the network parameters is in the economy tab right over here. Here's where you can view the current parameters used by the network, all these, along with a form for submitting a proposal to change them. When we click the vote button at the top right, we're taken to a page where we can view the current proposals submitted by users, and the default proposal for keeping the parameters as they are is at the very top. So that's over here. By clicking the caret icon.
Sorry, during the apply window, sometimes you don't see the default, so it just happens that we're in the window where like it's applying the previous proposal, so the default proposal won't be at the top. It just, of course, during the demo, you know, it just happened to be like in that window. But yeah, if you refresh, it's probably there.
Yeah, but if it was like if we weren't in the proposal window, you'd see it down here, and we'd be able to see like more details about it by clicking the caret icon underneath it. But so these are the main features that were in Liberdis. Now that that's kind of out of the way, I'll hand it back over to Kyle to talk about submitting swaps, which is a new thing that we added with PeerSwap.
Sweet. I'll go ahead and share my screen. All right. Can everyone hear me still?
Yep, loud and clear.
All right, cool. So with submitting swap requests, in order to submit those, you can either go to our wallet page, which is right here, and then click on swap here in the middle, or just from the dashboard, you can click swap right there. Amr and I will each submit a swap to the network using a different swap type. There are 3 swap types you can submit, which are immediate, offer, and request. They go from strict to open-ended. The immediate swap is what most people are used to, where I have something to give and I know what I want in return for it. The offer swap means I have something to give and I want to see what people will give me for it. And the last type of swap is the request swap. And the request swap is for when I want something and I want to see what people want in return for giving me the thing I want. So I'm going to select immediate as my swap type. And you can also see the information about the swap type when you select it. So I have some ETH that I want to swap for USDT. So I'm going to do ETH, and then the amount is 0.1 USDT, and then it's going to be roughly like 350, or I don't know how much ETH it's going for right now, maybe more like 4K. But for the blockchain address, I'm going to use something that I just paste in there. And the max time to send and max time to receive is the number of seconds each user is allowed to send their offer, starting from the time the initiator accepts the bid. The last input, collateral, is the amount of DAI each user has to put up as collateral for the swap. Ideally, this should be equal to the US dollar value of the asset you're swapping. And since ETH is mentioned, or is somewhere around 350 to or 3,500 per token, 0.1 will be roughly like $350 again. So there's that. And to submit, we just click the button at the bottom and we're good to go. Transaction queued. One thing to note on the immediate swap type is that the network automatically accepts the first bid that gets placed. And this is great for when you want the swap process to go quickly, and it's similar to what everyone is used to with services like Uniswap. The only difference being that you're swapping with another person and not a liquidity pool. So I'll pass it back over to Amr to demonstrate submitting an offer swap.
And there's my screen. All right, so I'm going to head over to the swap form and select offer for my swap type. So let me go ahead and do that. Swap form, click offer here. Since I have some ULT that I want to swap for something, I'll offer ULT as my token and use 5,000 for the amount. So ULT and 5,000, not 50,000. That'll be somewhere around $600. So I'll put $600 in the collateral. Oops, not 6,000. And that's it. We're done. I can submit the swap to the network. So I can go ahead and click swap down here. And that transaction queued pull for results means the transaction has been submitted. So now it's a good time to talk about the life cycle of a swap. Every swap has 4 potential status states that they can be in. So there's open, exchanging, complete, and disputing. Open means that the initiator has not accepted a bid yet, and the swap is open to users submitting bids. So you're only able to bid on a swap with the open status. Exchanging means that a bid has been accepted by some initiator, and both parties should be sending each other the assets agreed upon using whatever network they belong to. So like once I've done a swap and then it's gone into the exchanging status, that's when you should actually send the assets. So disputing means that one of the users hasn't honored the agreement and the swap is going to be reviewed by a jury. So this happens when during the exchanging phase, like something, gets messed up or someone didn't send the coins or someone suspects a foul play on the other party's part. So that goes into dispute and puts the status into disputing. And then complete means that both parties have received the assets they requested and had the collateral returned to them. So that's when a swap is completely over, the assets have been exchanged, it's all good. So I'll hand it over to Kyle to talk about the process of finding and bidding on swaps.
All right, sweet. Back to sharing my screen. Now that we've both submitted the swaps, we can search for them in the swaps page, which is right here. To easily search for the latest ones, we can head over to this date created column and hit this arrow twice so I can see the latest. I see Amr swap right here. And all the swaps that came before it, like mine, and just a couple that I used for mock data. This page gives you a lot of nice abilities like hiding columns, stacking filters, changing the density to be, show more on the screen or be more comfortable. Filters, like you can say, oh, show me only the swaps that, the token offered is like Bitcoin or whatever. And then you can stack filter with like operators like and or, and just, you can really fine tune it to find exactly what you're looking for. But right now I'm just going to hide that, showing columns. You can also like resize the columns and everything. So you can export them as a CSV. It's really powerful stuff. So in this action tab over on the left, I can hit this icon to go to that individual swaps page. So I'm going to hit it to go to Amr swap. And I see his swap info right here. And the form to place a bid and the bids that have been placed by other users down here. There aren't any bids at the moment, but we'll change that by requesting ETH or offering ETH in exchange for Amr's 5,000 ULT. I'm just going to offer 0.2 and then paste my mock address here. All right, and now you should see a bid appear in this section shortly. There it is, perfect. All right, so I'm done with placing my bid on Amr swap, and let's have him do the same for mine. So I'll pass it over.
All righty, put my screen up again. All righty, so I'm gonna head over to the swaps page, which is right over here. And I'm looking for Kyle's swap request using the find swap request from Kyle. So
I might want to just refresh it or
there we go.
Perfect.
Swap request, initiator alias, provider alias. There it is. So I found it right here, and I'm going to click on the tag and check out the page for his swap. So I click bid, and this is Kyle's swap page. Since Kyle used an immediate swap, the exact token amounts are already specified. So all I have to do is enter my address. And I'm going to enter my very real Ethereum address. This is not real, it's a fake address. And do place bid. And that should have sent the transaction. So let's wait and see what happens when the bid shows up. So it should show up down here shortly. since the swap is immediate, it should show up in the exchanging status state. So there it is, accepted. And yeah, immediate swap, I place my bid on it, right? And that has gone through. So now that we've both placed bids on each other's swaps, let's return to the dashboard and see what's going on there. Looks like I have a swap and a bid showing up here now. So under my swaps and my bids. In order to see the bids that have been placed on my swap, I hit the caret icon at the lower right corner of the swap to expand it. And I can see Kyle's bid here. All the info on this dashboard updates in real time. So as users place bids or accept any bids I make, you'll see it update. I could sit here and wait for more bids to show up, or I could just accept Kyle's offer. I'll accept the offer, but first I need to make sure he has my Ethereum address so he knows the address to send it to. And I will use the same Ethereum address from before for that. It's a fake address. Please don't send Ethereum to this. And that has sent the transaction. So we'll wait for the swap status to be updated to reflect that we're now in the exchanging state of the swap cycle. Like right now, when it's in the exchanging state, right over here, this would be the time where you actually go and send the tokens. So like I would send it to Kyle, he would send me his, and like we'd both make sure that everything is good. And if Kyle doesn't honor the agreement or fails to send the tokens altogether, I can hit this warning icon to send a signal to the network that something went wrong and that I want to open a dispute for this specific swap. So as mentioned previously, this feature is still in development, but that's how it would work. So now we can see that Kyle has marked the swap as successful. So I have accepted it, and Kyle has marked it as successful. And let me mark it as successful here. So now the swap has become complete, and all the collateral that I had put up before, the 600 DAI, I have gotten that back since the swap is now complete. All right, so let's go ahead and check out one more thing, the page for transactions, the transaction history page. So here's where we can see our transaction history we submitted to the network. Just like the swaps page, we can use all the powerful tools that we have for filtering to find transactions. Like, for instance, I could filter on various columns that we have here, like type, data, do operators for what those columns should contain and add a value. So like really powerful filtering tools. And then once I have the transactions that I want, I can click the export button to download them as CSV. And this is really useful. So that about wraps it up for our first demo presentation of PeerSwap. We hope you enjoyed it, and we hope that you try it out at peerswap.vercel.app. But make sure that you're not actually using this to send things with monetary value, because it's still in the development stage. It's not complete yet. So just be safe and don't use it to send actual money. But let us know if you have any questions, and we'll be happy to answer them after the second part of the presentation. So thanks a lot, guys.
All right, great. Thanks, Kyle and Amir, for that great demo. Just out of curiosity, on the back end, how many nodes are running for this?
Only 10.
Oh, okay. Yeah. All right, great. Yeah, but so this is a example of what can be built using Shardus. So you can build any kind of custom application, and very similar to how you build a e-commerce website. Kyle basically created the APIs and then created the front end client to interact with those APIs. So it's a very well established development pattern that's currently used for building lots of e-commerce websites, and developers can continue to use that same pattern for building things with Shardus. All right, so the other thing I want to mention is that if you're interested in helping us with this PeerSwap product that we're building, please contact us. Send an email to info@shardus.com, and you can help with helping with the beta testing of it, or if you want to help with the any kind of development or feature requests and things like that. So always welcome to have people, members of the community participate. All right, great. So with that, we'll go on to the main event, which is demonstrating a large network. And let me bring up my slide here just to recall what this is, and let me share the screen as well, just for a second so you guys can see it. All right, so yeah, so we're going to do the main Shardus demo. So we're going to try to go and hit 5,000 transactions per second. This is going to be on a network with 1,000 servers running on AWS. They're across 20 different data centers around the world. The hardware that we're using for each of those servers is a T3 Medium, which basically has like 2 CPUs and 4 gigs of RAM. So it's a pretty cheap server. It's like 4 cents a minute, and yeah, so it's commodity hardware. You don't need any specialized hardware to run Shardus networks. And we also have 20 separate servers running on Linode for submitting transactions and adding load to the 1,000 servers that are running on AWS. And keep in mind that these transactions that are being submitted, they're real transfer transactions from one account to another, and each of those is digitally signed. And so the network has to verify the signatures and actually update the database to transfer the asset from one account to another. So these are real transactions that, and the software that we're using is the application software is the same as Liberdis, and we've demonstrated Liberdis in the past. So this is a network of 1,000 Liberdis nodes running at the same time. So, okay, with that, let me turn it back over to Andrew and Amir, who will then demonstrate this network for you. Take it away, Andrew.
All right. Can you see my screen okay?
Yep. Looks good.
All right, cool. So I think Omar mentioned earlier that we had to update our monitor, and Tant on our team built us a monitor front end for representing lots of nodes. And so it's going to look a little bit different than some of the previous presentations if you've watched those. And part of the focus was just something that we could do thousands or more nodes and be able to still get a sense of what's going on visually. One of the changes is our nodes used to be like circles within circles to show state, and we kind of simplified that and changed up our color scheme. So right now we have 1,024 nodes that are all active and in sync, and now the green represents kind of that they're both active and in sync with the network. We have different views. I switched to different view here, and it takes like a second to refresh because the refresh rates, when you have 1,000 nodes sitting up telemetry or more nodes, you kind of want to like lower the refresh rate a little bit so you're not overdoing your visualization servers. So basically, and I think that's refreshing a little bit slow for me. So I have some different views I can go through. Try that one. Show node list hash. Back to data sync. All right. Right now, there's no spam happening, and we kicked this network off a little bit before the meeting started. I grabbed a screenshot earlier in the meeting while other people were talking. So we see these yellow nodes around the ring here are nodes that we're joining into the network. And one of the things we had to change compared to previous milestones is to actually start building up this many nodes. We needed a faster network assembly time. So I'm going to switch over to our node sync timeline here. And what you can see is it's an exponential curve. And that's just because the more nodes you have in a network, basically the faster we can add nodes for a given cycle. These lines here are our cycles, which kind of represent a phase in time where the network looks at accepting or rejecting nodes and rotating and whatnot. And basically, it started out growing kind of slowly, but as the network got larger and larger, it was able to sync more nodes at a time. And these straight lines here, actually, if I zoom way in, each one of these hashes is a node joining in on that cycle. And occasionally you see like a dash versus a line, and that's just kind of representing the time a node takes to synchronize in. But everything looked good on this. Let's see. I think we're ready to get some spam started on this. Amr, do you have some spam ready to go?
Yeah, let me go ahead and share my screen to
Cool.
show you guys what the spammer tool looks like, because that thing made a really cool orchestrator this quarter.
So just to clarify, the spam are not like fake transactions. They're actually real transactions. So we refer to it as just spamming the network, but it's really sending many actual transfer transactions and create account transactions.
Yeah, that's right. And so let me go ahead and open up the app. The spam orchestrator. That's something from an 80s hacker movie,
Yeah,
which I really like. But yeah, so we have on the left there, we have a list of the 20 nodes, Linode servers that we've spun up and orchestrated from the orchestrator to be our spam nodes. And in the middle, you can see a terminal into each one of those nodes. And on the right is kind of a summary of the standard output of the spam that each one of those guys is going to give us. So, Andrew, you said you're ready to spam the network, right?
Yes.
All right, so let me go ahead and copy the spam command that I had set up for this and for this specific network. And let's start with about 2,000 TPS. So each one of these spam clients, each one of these spammers that we have is going to do about 500 transactions per second. And to get to 2,000 transactions per second, that's going to take about, let's see, about 4 of them should be good for that. All right, so go ahead and paste this. And I have the right monitor server and start the spam. All right, so the awaiting there means that it's going to spam the network at 500 TPS. So let me go ahead and start the other 3. Let's get the command here. All right, we're at 1,000. That makes it 1,500. And that should be 2,000 TPS. Alrighty, so I'm not sharing the network window with you. Maybe Andrew, you can
Yeah, I'll switch
network.
back.
Yeah. But you should see the process transactions going up and the average transactions per second climbing up on the network.
All right, I just started sharing my screen. Is that showing up?
Yep, you can see it clearly.
All right. And I'm getting a little bit of echo.
Oh, go ahead.
Thanks. Yeah, so one thing we had to do for the large number of clients monitor is to turn off some of our animations for now. So we don't quite see the little red dots coming in like crazy on previous tests. But what we do have is we can see the transactions per second, and the way the timing is in our individual spam clients, we're not seeing exactly 2,000 here, but that's just kind of the way that the timing works in the clients. It's probably really sending out about 1,600, but we can just balance that. We just start more and more load until we get to what we want to see actually observed. And I have a graph open. Let's see, or do I? Here it is. Yes. All right. So this is our network performance chart. And this is another way to view what's going on with our network. You can see earlier where we had the network building up a number of nodes is this gray line here. And blue is the number of transactions per second. And these are transactions that are actually going through the complete like processing, voting, generating receipts, and being agreed upon by the network. We also have a network load that's kind of an aggregate and computation of several factors, and it's what's used to decide the network scaling. To make this test easy, we went ahead and said that we wanted this network to kind of be at max node, so it's not really bothering too much to try and decide if it needs to grow or shrink, because we wanted to kind of demo at a specific network scale. What we can also see is the internal load of nodes, which is nodes kind of all reporting their time spent processing messages, and that gets aggregated. But things look great. So I think, Amber, we can go ahead and ramp up and add another 1,000 TPS or two spam clients.
Yeah, sounds good. Let me go ahead and so we have Atlanta, Dallas, Frankfurt, and Fremont going on right now. I'll go ahead and add London.
Cool.
And New York.
And I'll keep it on my screen, and we'll see this this graph jump up as we just keep adding more and more transactions per second.
So we have another 1,000 TPS coming in now.
Nice. Yeah, these are unique signed transactions for different accounts, and they're basically hitting the network all over. So it completely randomizes which node gets the transaction, and the nodes route it to the correct shard. So this network is has a high degree of the network's sharded into quite a few pieces, and that's where we get our linear scalability. So a message will land in the network somewhere, get routed to the correct nodes that need to actually process and validate the data, and save it off. So yeah, we saw our transaction rate jump, and the internal load jumped a little bit as well, and I think that looks pretty good. Let me go here. Yeah, we see it showing about 2,500 TPS as far as, I think that's what's actually getting to the network. So I think we could add another 2 spam clients to that.
All righty, sounds good. Let's go ahead and bring on Singapore.
Yep.
And Sydney. And this ups the outgoing spam to 4,000 transactions per second, right?
Mm-hmm.
Cool. And we should be seeing that reflected shortly in the network monitor.
Yep. yeah, and it really became necessary, this milestone, to have this orchestrator, because just the work of creating and signing the transactions and then the load on the machine's network makes sense
absolutely.
to have to start doing that from many computers.
Yeah, the orchestrator is a huge help. Great piece of code by Jairaj.
Mm-hmm. So one thing that's nice is our rejected transactions per second is still 0. If the network gets overloaded and nodes start to get too busy, they start rejecting transactions, which is a good thing, because it's much better for a network to understand its capacity. And if it gets too busy, start saying, no, we can't take this transaction. But at the same time, in our live networks, like we demonstrated last milestone, that's when the network also says, okay, we're ready to grow. And so more people that are waiting to run nodes in the network can get into the network. And that looks good. We've processed 960,000 transactions so far. I think we can add another 2 spammers to that.
Alrighty, sounds good. So bring on Tokyo and Toronto. And that brings us to a total of 5,000 TPS outgoing spam.
Mm-hmm.
Just to kind of put into perspective what these TPS numbers are like. So the Bitcoin network does around 5 transactions per second. Ethereum does about 20 transactions per second. Some of the other newer networks that are coming up, which are, try to, give a lot more scalability at the cost of reducing, the decentralization. Some of those networks are getting into the hundreds and thousands of transactions per second. So as an example, like if you take all the traffic that goes into the Ethereum network plus the Binance Smart Chain network plus the Polygon network, and you look at what's the max daily transactions per second, that would, or max transactions per day, that would come out to about like maybe 25,000 or 25 million transactions. And if you're able to process, like say 300 transactions per second, you multiply that by the number of seconds in a day, you find that that's actually a number bigger than 25 million. So even at 300 transactions per second, one could handle all 3 of those large networks right now. So we're right now 10 times above that, and I think we should be able to go even further. So
Yep. Yeah, and I think also Omar mentioned it before, that these nodes are not like monstrous nodes either. They're just T3 mediums, and we even had some success with T3 micros a week ago, and I think that was running pretty well at 2,500 TPS, or maybe a bit more. And let's see. But this network is still looking pretty happy.
do you want to add more?
Yeah, we can add another 2 spammers.
Alrighty, let's do it. So bring on the second Atlanta spammer and the second Dallas spammer. And that brings us to a total of 6,000 TPS outgoing now.
Our internal load has been ramping up consistently with each increase in load. Our external load actually was flat across the first 2 levels, but then it's continued to go up with each level. and we can see that TPS just going up. All right, I see a 5,005 there. And I think at this rate of spam, it's probably going to bounce just right around the 5,000 region. And the network's looking very happy right now. In a second, I'll tab over and take a look at what.
I did see a couple of transactions getting rejected there.
Oh yeah, okay. So what can happen with that in a really, yeah, we had a little bit of transaction rejection there. Out of all these nodes, maybe a little, one or two of them might get a bit over busy for some reason and say no to a transaction, but what would happen then is it's such a small rate compared to what's being processed overall, is the client could just resubmit their transaction. It worked fine. Yeah, our nodes are running pretty nice. It looks like they're running about 20% of their CPU. So their CPUs aren't even cooking that hard to keep up with this load. But that's just the power of how the network's able to split up the data and transaction load. And we're at, what do we got here? 2 million transactions have gone through, 2.4 million transactions.
Yeah, that's pretty cool. So yeah, we've hit our, 5,000 transactions per second. Now I know if we started pushing this network even higher, eventually we'll get to a point where like many transactions will start getting rejected. The higher we keep pushing it, and then eventually we in the lab we've also pushed this to the point where some nodes may fail just because of not being able to keep up with the amount of traffic and so forth. But that's we're not going to push the network to that level here. But the way the Shardus network is designed is that more nodes would be able to join the network at that time, and then as you have more nodes joining the network, the whole network is able to handle more transactions per second, and so should be able to process more. If we were to go to like 2,000 nodes, we could actually get to 10,000 transactions per second and so forth. So, but yeah. Anything else you got a demo here, Andrew?
No, I think that's good for this demo. Yeah, when we're testing, it's always fun once we've sort of hit our goals and gathered the data we need for the rates we're shooting for. I think pretty much every time we also enjoy just then ramping things up until we eventually find a breaking point, because learn something new each time where we push it just too far, and then gives us small things to fix.
Yeah, it's been amazing this last quarter, just like watching the progress these guys have made, and watching them spam the network and hit these crazy numbers like 10,000 TPS and 8,000 TPS, and it's only 1,000 computers. Like we hit 8,000 TPS on 1,000 computers, which is just insane. But I don't know. I'm biased.
Yeah, no, definitely we're making progress and heading towards the day when we should be able to do like 1 million transactions per second kind of numbers. All right, great. So now one thing I wanted to ask, like you kind of ramped up the TPS at 1,000 at a time. Could we have just gone from 0 to 5,000 TPS all at once?
Yeah, that would have been fine.
Okay. All right, great. And maybe, Amr, if you can maybe turn off the spam, and then we can see these lines fall back down to zeros.
Yeah, sounds good. I'll start. I'll kill all of them at once.
All right. And while that's happening,
What's that?
Kyle, you wanna somebody say something? No, I was just gonna say, while you're doing that, Amir, maybe Kyle can start taking some questions that we might have.
Sure. I don't see any questions currently in the YouTube live chat, so.
Okay. So yeah, let me just kind of let people know that if you have any questions, feel free to post in the YouTube live chat there, and then Kyle can, you know, route the questions.
All right, and spam has been killed, so you can see that being reflected in the charts here. Oh, let me post a link to PeerSwap, the PeerSwap demo in the chat to give people a chance to try it out.
So just keep in mind that this is not a network that's going to be constantly running. It's just something that you could try now, but we're probably going to take this down, shortly. But it just kind of gives you a chance to try it out. But we're definitely looking for people to help out with testing PeerSwap, and maybe helping with development or feature requests and things like that. So.
Omar, we got a question from the Growth Mindset. He's asking, how many nodes would it take to get to 1 million TPS?
Okay, so that right now with this network, we could do that with, let's see, what was it, like 5x, right? So with 100,000 nodes, we could get to 500,000 transactions per second. So with 200,000 nodes, you could get to 1 million transactions per second. Now, of course, it also depends on what kind of application you have and what kind of transactions you're doing, right? So we are doing like, just asset transfer transactions here. If it was more complex transactions, they may require, more load, and so you might not be able to achieve that. But yeah, it depends on your workload, what kind of transactions you're doing. The other thing it also depends on is like how many nodes you want to have in the shard. So currently, we've used just 5 nodes, or shard size of 5 nodes, or is it 10? Andrew, do you remember?
The data is getting shared across 10 nodes.
Oh, okay. Yeah, all right. So it's basically like a shard size of 10 nodes. And so if we were to increase the shard size, then you won't have as many shards, and so you won't be getting as high of a TPS. So it depends on your application as well. Like this kind of a network could be used in a enterprise setting where it's not like a public network and you have some sort of a federated network. But in a public network, you might want to use something more like 100 nodes per shard. And so, with that, then, your TPS would go down by like a factor of 10. So yeah, hope that answers your question.
Cool. That's about the only question so far. So if anyone else has anything they want to ask, feel welcome to submit.
All right. Yeah, and we're planning on having the next step would be adding more dispute resolution features to PeerSwap. We're planning on doing that this next quarter, and hopefully by the end of next quarter we might be able to have a test net up for PeerSwap that people can start playing around with. Also, with Shardus, we're hoping to maybe get to a state where we can use 10,000 nodes and demo that. and we should be able to go to like 50,000 transactions per second. That would probably put us like among the fastest in terms of the most throughput blockchains that are out there. I don't know of any other blockchain that's actually used sharding to get to this level of TPS. But yeah, so it's you know we're steadily making progress. I feel like we're setting goals and then slowly working towards those goals. It's kind of like sending a man to the moon. You can't just do it on the first shot. You first see if you can send something that'll orbit the Earth. Then you try to send some people that orbit the Earth. Then you send somebody to go orbit the moon, and then finally you send somebody to land on the moon, and you kind of work your way up. So that's kind of what we're doing, and each quarter we demonstrate what we're doing so that you have a view into what's going on in the project. We're not constantly on our social media channels because we're busy working on the code. But yeah, we are making progress, and if anybody's interested in trying out Shardus, if you have a project that you think might benefit from Shardus, definitely get in touch. We'd love to talk to you and see how we could help you with the project that you have going. So
Sweet. So
all right,
we got 2 more questions actually. Now.
Okay.
So a chef is asking, are there unique transactions? Do they include protocol transactions, or are these unique transactions?
Yeah. So that's a good question. So these numbers that we saw where we achieved like 5,000 transactions per second, these are all application transactions. If we were to include like the internal protocol transactions, uh, it would probably be at least 20 times more than that. So we've probably already hit 100,000 transactions per second if we were to include the internal transactions. Um, yeah, so these are only the application transactions. So they're unique, sending from account A to account B type transactions or creating a new account. So. What was the next other question, Kyle?
Okay, so the next question is on rejected transactions. So in a current life scenario to get an apple to an apple comparison. So he clarifies by saying, if I'm making a purchase using a MasterCard, then what does the rejected transaction equate to? Would I see something that equates to card declined?
No, so actually what it would equate to is rather than your transaction taking 5 seconds, it might take 10 seconds. So what would happen is your client would automatically see that the transaction was rejected and then maybe wait like half a second and then submit the transaction again. And that transaction would potentially be routed to a different computer, and that computer may not be as loaded as the first one that you tried to submit it to. And then that computer could, accept the transaction. So you, in a real world application, you wouldn't see that your transaction is rejected. You would just see that maybe it took a little bit, few more seconds to process than it normally does.
Sweet. And he had a second question, which is, what is the definition of a transaction? Smaller transaction versus larger transaction will yield different TPS.
Yeah, exactly. So the definition for the transactions that we're doing here is basically a transfer transaction, right? So you have some assets in one account, you want to transfer those assets to another account. You create a transaction that says, here's the from account, here's the to account, here's the amount, and then you have to digitally sign that transaction. And so our spam clients were creating transactions like that, submitting them to the network, and the network was actually validating each of those transactions to make sure that the digital signature is correct, make sure that the source account has the coins in it that it wants to send, and so forth. And then finally, once the nodes consensed upon that transaction being valid, and that it should be applied, then the set of nodes that handle that account actually updating their database to make that change. So that's what was happening with each of these transactions. And yeah, so if you have more complex transactions, it could take put more load on the system, and you wouldn't get as high a TPS. But typically in the industry, when people are doing comparisons of these blockchain networks, they're using fairly simple, asset transfer transactions.
And a nice kind of thing about these transactions is how we separate out the effort in dealing with one. So the Shardus global server framework that the apps are built on deals with the math needed to, share these transactions and account data to the correct other nodes in the network, and also deal with consensus and that sort of thing. Whereas on the app development side, you're writing a function that says, well, you write one that says, hey, does this transaction look good? Like, are the fields okay? And then another one that's Kyle can correct me because I'm maybe a little rusty, but like, can we apply it? And it's at that point it's given. When you're like writing that code, you'll have the transaction data right there, and you're just like, well, if it's a transfer, I'm gonna subtract out the balance here and add it here, and
yeah, very simple from the app developer's point of view. Very simple. Like, I mean, we basically got PeerSwap up and running in about a quarter. So, I mean, and there's some complex stuff going on, like you got to take out collateral, and you got to validate that like they have the collateral to put up for the swap in their account. Yeah, I mean, there's just a ton of stuff, but Shardus makes it, I mean, easier than anything else that I've ever used. Like,
yeah, PeerSwap has some non-trivial transaction types in it, and that's just kind of a good way for us to push ourselves.
Yeah, and especially the network parameter proposal stuff that we demoed in Libertas, all that kind of stuff is, you got to be really secure, but I mean, it's just, a couple validation steps that you put in to make sure that, only the proposals that get voted on by above a certain margin against the other proposals, like, you got to make sure that happens in order for it to go through and to be able to affect the network parameters.
Awesome. Any other questions, Kyle?
Let me check real quick. No, I think that about wraps it up for the questions. So.
Okay. Yeah, I think we're pretty close to our 1 hour time. We started a little bit later. So yeah. Well, thank you all for joining today. Hope you enjoyed our presentation and got to see a little bit of what we can build with Shardus through the PeerSwap demo, and then the core capabilities of Shardus that we're continuing to enhance further and further each quarter. And right now we can demonstrate 5,000 transactions per second, and hopefully in the future you'll see those numbers going up. So yeah, appreciate everybody joining. Thank you so much.
Thank you.
Thanks, guys.
Thank you.
Thanks a lot.
Thanks.